How does a tree grow? Why does the wind blow? When does a flower bloom? How can a rocket shoot to the stars or land up on the moon? It's science and technology, engineering, mathematics. Get smart, keep it simple. Let's learn about STEM. Hello friends! Today we're going to talk about volume. What is volume? Volume is the amount of space that something takes up. So everything around you that is taking up some amount of space has a volume. How do you know how much space something is taking up? How do you solve or find the volume of an object? Well, if it is a geometric shape, it has a defined volume based on a mathematical equation. Some different shapes like cubes, rectangular prisms, pyramids, cylinders, spheres, all of these things are going to have a mathematical equation associated with them in order for you to plug in their dimensions or measurements and solve for their volume. So I've got this cube here. This is my Rubik's Cube, and we are going to measure it. The mathematical equation to solve for the volume of a cube or a rectangular prism is length times width times height. So you've got your length here, your width, and your height. So I'm going to measure using inches with my ruler. This measures to be about 2 1/8 inches, but I don't want to do the math for 2 1/8 inches in my head right now. So we're going to call that an even 2. So we've got a width of 2, we've got a length of 2, and we have a height of 2. So what is 2 times 2 times 2? You've got 2 times 2 is 4, and 4 times 2 is 8. So the volume of this cube is 8 inches, because we measured in inches, cubed. So that means an inch times an inch times an inch. So 8 inches cubed is the volume of this Rubik's Cube. But how do you solve for an object that's not a perfect sphere, or it's not a perfect cylinder, or it's not a perfect cube? How do you solve for the volume of that? Well, one way is you could use the principle of displacement. What's displacement? It's the original volume subtracted from the new volume. So right now we are sitting at 56 cups of water in this fish tank. So if I wanted to solve for the volume of this pumpkin, I can push it down in here and we can see what our new volume is. We're almost right at 60, so this little pumpkin has a volume of about 4 cups. We could even solve for something as crazy as this monster truck. And although it looks pretty big, a lot of what's going on in here is empty space. So if we can put it in here and make sure the water fills all these empty cavities, it may not actually fill, or it may not actually be that much volume truly. So you got all these cavities kind of filled with water. He's still wanting to float a little bit. Whoa! These tires must be filled with air and wanting to float a little bit. So what does that give us? Let's see. It's pretty close to 2 cups. So each of these lines that I did is 4 cups. So every 4 cups of water, there's a new line. So this is about halfway between 56 and 60. Is there a better way that we could solve for what the volume of this monster truck is? Well, yes. I can take this measuring cup and I can scoop out some water until we get back down to 56, our original volume measurement. Take out a little bit more. We're close. Take a little bit more. That's pretty close to where we were. So let's look here. I said it was going to be about 2 cups. That is looking almost right at 1 3/4 cups. So using some backwards math, we started at 56 cups. It bumped us up to about 58. We could kind of see it was close to 58. We scooped out what the difference was. So we scooped out enough water to where it knocked us back down to that original 56, and that was about 1 3/4 cups of water. So our guess of 2 cups was pretty close. So using the principle and applying the principle of displacement, we were able to solve for the volume of this monster truck. So I'm going to pull this monster truck out. Try to shake it off a little bit. We're going to pour our water back in, so we go back to that 56. I've got one more thing. I am very curious to see what the volume of this marble chess set is. I got this from an estate sale, and I glued all the pieces down, and we'll see. Okay, well, the whole thing doesn't fit. So is this going to be is this change here going to be an accurate representation of the volume of this chessboard and all of its pieces? No, because these pieces are not submerged in the water. So from this water level here, all of this that's out of the water, the volume of that is not being accounted for. So if you have an object that's too big and you can't completely submerge it in your tank or in whatever you're experimenting with, that is not going to be an accurate representation or an accurate number to give you the volume of that irregularly shaped object. So from here down, this chessboard's about 3 cups, but I guess we'll never know. Thanks so much for tuning in. I hope you learned about volume, and we will see you next time. Bye! Thank you so much for watching. Here are some other videos you might like. And make sure you subscribe so you can see when new videos are uploaded and we can keep getting smart, keeping it simple, and learning about STEM.